Any doubts before starting, like in the last lecture or so? Any doubts are there?
No, ma'am.
So, as this is our, I think, second last lecture, if I'm not wrong.
Yes, ma'am. 7th.
Seventh lecture, but I'll take one extra lecture as well, maybe on Sunday, next Sunday. So I have informed the NPTEL basically for the next lecture. So basically, 9th lecture will also be taken. Next Saturday, Sunday, we'll go. I'm not sure about that. Probably we'll have both the classes on Saturday as well as on Sunday, 5 to 7. So that we can do more practice problem, and whatever will be the remaining stuff we can cover on Sunday itself. I think most probably on Saturday or I think half an hour we'll cover the remaining things, and then we'll go for the revision part. So now coming to, I'll just go through whatever we have done in the last class, and then we'll come up with the today's class. So we did drunkard walk. I'll just revise it as fast as possible, and so that we can get a clearer view what we have done, and we can revise also. Drunkard view in one dimension, we did basically that problem, and then we looked at it that it can be multi-dimensional also, where we saw that page rank and all. And then we saw the memoryless property, how the geometric distribution itself is memoryless, because it doesn't depend on how, like suppose we took an example of the bus itself, like it doesn't depend how much waiting time of the bus, it doesn't depend how much time you have waited already, it depends how much time you need to more wait. That is basically. And then we came up with the Markov evolution of the Markov chain. I hope so that Markov chain is basically clear to you. And then this was the homogeneity and the stationary distribution. And after the stationary can you tell me what is stationary distribution before I should jump?
Ma'am, if the limit exists for the Markov distribution.
How we calculate stationary distribution, you know that. Like there was an example there was a like assignment problem also, I think, if I'm not wrong. Is it so, like to calculate the stationary distribution? Can you check one? Yes.
1 minute.
Your voice is breaking. Hello. Am I audible?
Ma'am, I don't remember. I need to look it back.
Okay. So you know how to calculate the stationary distribution? If
yes,
we have, so basically, what does it tell? Like when we are going on transitioning, like we'll end up with the same probability after so many. When n tends to infinity, after so many rounds, we basically there'll be an equal like the probability distribution will not change. Am I correct by saying this?
Yes, ma'am.
Okay.
Yes, ma'am.
And can you tell me about regular Markov chain? What is the Markov chain? Yes. Come on. Go through the previous lecture notes. Basically, if I'm doing m square and cube, basically all the entries of m power t should be basically, yes, come on.
every transition is possible.
Yes, every transition is possible. Like we were
Is zero.
we were discussing about irreducibility as well as I was telling you, na, like last time we were having confusion. Like I was telling you that how can they say that you remember that thing, that how can they say that 0.5 or something the Markov chain can, okay, I'll come up, that how basically ergodicity means ergodic Markov chain means it is irreducible. What is irreducible? We can go from any state to any other state. That is irreducible. That is basically ergodic Markov chain. And regular Markov chain means basically it is regular if all the entries, if I'll do m square, m cube, and so on, all the entries should be greater than basically the zero thing. And I think the regular Markov chain is aperiodic also. But in ergodic Markov chain, it is not the necessary condition. I think so. That is what is the difference here.
Yes, ma'am.
Now, coming to page rank. Then we did page rank. Can you, okay, this was this. Now, can you tell me what was the page rank algorithm, how we did that page rank, and what is the main motive of this page rank, how we came up with this page rank, what were the strategies? Can you just summarize it in short so that we can proceed now? So that I can understand.
Yes. Our problem was to rank pages based on whatever the first criteria was the in degree they are having, and we had some limitations, like it could be a trap or something. That's why we moved to second strategy, that is we considered the other website rank also, which is connecting to it. And,
that is what strategy 2 says.
And then after that, we also considered string, that is to jumping from one website to another without having a direct link to it. Strategy 3. Strategy 4, when we were discussing about ergodic process.
Yes. So basically, we discussed about strategy 1, where we, as you have told that, very well told that it is only about the in degree, but not telling about how important that each web, like suppose web pages, and maybe it can be a fraud, as you told. Now, basically, whosoever is whichever web pages are in link are the in links for that particular, how much weight it contains, how much important it is. So we should see the ranks of that also, as you told. And then basically the trade-off between exploration and exploitation should be there. Suppose we have it shouldn't be like this is the one, they are connected to each other, so we can't get connected this to this because they don't have a common link. So sometimes exploration is also necessary. And then we also learned about some of the map problems, RL problems, about how exploration and exploitation plays a role in them. And then we saw about the this regular Markov chain and all. Now coming to the next topic, and how to make the Markov chain regular. Can I say if it is aperiodic, how to make it, if it is periodic, how to make it aperiodic? Basically, by adding the self loops, I can make it aperiodic. If it is going from here to here, here to here, so by adding this self loop, so that it shouldn't be like the periodicity shouldn't be there. So by adding this self loop, I can make the chain aperiodic, Markov chain aperiodic, and make it regular basically. That is our main idea, how to make a ergodic Markov chain regular or aperiodic chain, aperiodic Markov chain. Got it?
Yes, sir.
So if you have, simply I want to see, maybe I haven't covered how to calculate the stationary distribution of this. Any idea? Basically, we have pi is equal to pi m. So pi 1, pi 2. You'll calculate, or I should show because we haven't discussed.
Ma'am, first you show an example, and after that we will take.
Yes. So pi is equal to pi n. That is basically our. So I can say that pi 1 is equal to. I'll say here. It's pi 1, pi 2. Pi 1 is equal to multiply 0.5 pi 1 plus 0.4 pi 2, and pi 2 is equal to 0.5 pi 1 plus 0.6 pi 2. And what is pi 1 plus pi 2? I can say that is equal to 1. Can we solve and get the what is the stationary distribution from it? Is it possible or not?
Yes, ma'am.
So let's solve it. So it is equal to pi 1 minus 0.5 pi 1. What is it? Minus 0.4 pi 1 is equal to 0.4 pi 2. So pi 1 is equal to minus pi 2. Can I say this? So if I substitute this here, pi 1 plus pi 2, what is pi 2? I can say minus, something is wrong. I think this is not the Markov chain. We can find the, or I'll take the simple stationary distribution. I think this is, it doesn't exist. The stationary distribution doesn't exist. If I take simple one, which we have done here, I can say here, what is this Markov chain? That one state, second state, first state is going to second, second is going to first with 1-1 probability. This is the Markov chain. Is it correct? This is the transition matrix. Is it correct? So pi 1 is equal to pi 2. I can say here, see, pi 1 is equal to pi 1, pi 2, 0, 1, 1, 0. So I can say that pi 1 is equal to pi 2, and pi 2 is equal to pi 1 by this multiplication. And we know that pi 1 plus pi 2 is equal to 1. So substituting this, can I get pi 1 is equal to 0.5 and pi 2 is equal to 0.5? Is it correct? You got the intuition or not?
Yes, ma'am.
I think here, yes, come on.
But if the stationary distribution doesn't exist, then we don't get pi 1 and pi 2.
If that is what I was seeing, maybe in this example I took as it is, like without thinking. So maybe in this example, I think either we have done some mistake, or can you check? Is it some mistake, or but 0.5 pi 1 plus 0.5 pi 2 is equal to pi 1, and 0.5 pi 1 plus 0.6 pi 2 is equal to pi 2, and pi 1 plus pi 2 is equal to 1. And this is minus 0.5 minus 0.4 pi 1 is equal to 0.4 pi 2, pi 1 is equal to pi 2. So if pi 1 is equal to minus pi 2, maybe here's some stationary distribution. Basically, my main idea was to show that how the stationary distribution we can calculate. So I think in one of the, you can open, I haven't calculated though, you can see assignment 6 here. Can you open that? Question 5. 1 by 10, 1 by 10, 2 by 5, 2 by 5, 1 by 2, 1 by 10, 3 by 10, 1 by 10, 3 by 10, 1 by 5, 1 by 10, 2 by 5, 1 by 10, 3 by 5, 1 by 5, and 1 by 10. Can you calculate the stationary distribution of this? Let's take 5 minutes and calculate, and then share the screen and show how you have calculated. Now, is it possible, or you are having the doubt still? Yes? Or I should solve with you?
Ma'am,
Yes, yes.
ma'am, in this question, ma'am, it is some doubly stochastic. Ma'am, that's
Okay.
why ma'am,
Okay.
it's
W.
regular.
What is the stationary distribution of this? What do you think? Will the stationary distribution change with the being doubly stochastic?
And column vectors also sum up to 1.
What is the difference between stochastic and rows? Like that is basically only rows are not summing up to 1, as you told that column vectors are also summing up to 1.
It's from W.
So is it not more easy or is it tough? Okay, I'll give you just a homework problem. I want you to solve and just to show me. Or should I wait now and or in the next class you can show me?
Ma'am, what you said, ma'am, can you repeat, please?
What I'm saying is, let us take it as a homework problem. Share your screen next night, like in the next class, and you can show me how you are calculating the stationary distribution.
Ma'am, but ma'am, if there was a property, ma'am, we were given, ma'am, that if M is W stochastic, ma'am, we get uniform distribution.
Okay.
That's why.
Okay. I was thinking to calculate it. Yes, absolutely correct. So that is 1 by 4, 1 by 4. Okay. So I shouldn't have given this something else. So basically, it's very easy rather than solving it. We can say it's a uniform distribution. Yes, I forgot that. Absolutely correct. So you can simply say that is why you were mentioning that it's doubly stochastic, and I was saying why he's
Yes,
mentioning.
ma'am.
Okay. So we can simply say it's 1 by 4, 1 by 4, 1 by 4 because it's uniform distribution. But you got to know how to calculate it by this 0.5, like how we got this 0.5 and 0.5.
Yes, ma'am.
Now,
We need to solve for 4 unknown variables for that question.
yes, what you're saying?
Ma'am, we need to calculate for 4 unknown variables for this question.
Yes. Now coming to next topic, cell genetics, an example. So basically, what they are saying is that cell of the organism, suppose it contains in particles of two types, A and B. The cell reproduced by first doubling. I'll just write it and then we'll go through the question and then we'll come up to this. And one more thing, can you tell me in which topics you're having doubts and all, or which topics you want to go through it again? So in the revision lecture, we can I can come up with the practice problem for that, more focusing on that problems. Yes. So what they're saying that n particles the cell of organism contain. So, and the cell is reproduced by first doubling the particles and then forming a child cell. Basically, first they're doubling that particle and then forming the child cell with random n particles. And now what they're asking is, what is the gene pool? After a long time. So let's first define this PJK. Now what we are saying is that we have the parent. First we'll double the particles of the parent and then form the child. And then what is the gene? After a long time, when we'll keep on repeating, what is the gene pool? Now let us define this PJK, which we define it as probability that parent has suppose JA types and child has KA types. Any doubt? Can you explain me what I have written first? Then only I can proceed. Yes. What is the question? Can you tell me what is the intuition behind the question? What I have written PJK and how I'll proceed forward? Come on. Yes. What do you think? Come on, anyone? You didn't understood or just the question it's written?
Out of J cells, child inherited K cells.
Out of J, K cells are inherited by the child. Yes. And what is the question? As
What
you
is the
said,
gene pool after?
now as you said that out of J, K, is it correct? Or there is something missing? I'll write the other. This is the A gene. I'll write the B as well. But is it correct what you are saying? Or something is missing here? Out of J, A types parents, K A type are, how much A K A type are basically there? Basically JCK I can say. Is it correct? From J, how many Ks?
Some parent had doubled, that's why I'm 2J.
Yes, that is what I was saying, that whether you all are concentrated. Now what should be of B? How many are total?
Some 2N.
So what should be of B?
2N minus 2J.
Can I say this?
Yes, ma'am.
So A is basically K out of 2J and B is basically N minus K. How many are left basically from, if K are there, from total N minus K are left, which are of B. And here also 2N minus 2J. So basically like N minus K like out of 2N minus 2J. So probability is the number of ways basically to choose A. I can say to choose K type, A genes from 2J, A genes, and probability of N minus K B genes from 2N minus 2J B genes. Over total. Can I write this? What does it mean? Can you tell me what is denominator and can you tell me whole now what I have written PJK so that it should be clear? No doubt should be there.
Out of 2N, we have to select N cells.
Out of 2N, I have to, this is overall basically number of favorable outcomes over total. And out of them, I can say A genes and B genes, I can say that. So we call it as hypergeometric distribution. First of all, what is this hypergeometric distribution? And why we are calling this as hypergeometric distribution? Any idea? Come on. Think that how it is hypergeometric. What is geometric distribution? First, can you tell me? Then we'll come with hypergeometric distribution. What is geometric distribution?
Ma'am, we repeat the experiment till we succeed.
Yes. Can you repeat again?
Ma'am, we repeat the experiment till we succeed.
Yes. So basically, we repeat the experiment till we succeed. And now, what is done here? Basically, hypergeometric is,
And we are repeating geometric distribution many times. Is it correct?
yes. I'll write the definition. Probability of drawing, then we'll go. Specific number of success, without replacement, from finite. We are given with the finite population, like this many number of times I have to repeat. And then the total number of success, what is the probability of having that total number of success? So let us take an example of hypergeometric, then we'll come up with that. Suppose I have n is equal to 52 cards and k is equal to, I have 26 red cards, and I can say 10 cards are drawn. And what is the probability that k is equal to, basically out of this 10 cards, 5 red cards are drawn. Or I can say probability of drawing exactly 5 red cards when you randomly select 10 cards from 50 cards, out of which I can say 26 are red. Now, can you tell me again? I haven't told you what is, I haven't explained you the example, just written the example and hypergeometric distribution. Can you explain me the example and hypergeometric distribution now with the definition as well as the example given? Yes, try at least. Come on.
Ma'am,
Come on.
we have
Mhm.
26 red cards. Ma'am, so out of 26, we have to select 5 red cards, and remaining 5 cards we have to select some other remaining cards. That is, other than 5 cards we have selected. And
What is it?
is
Suppose
divided.
we have 52 cards. I have to select 10 cards out of these 52 cards. And what is the probability? I'm saying that suppose the probability of drawing 5 red cards is success. So what is the probability of drawing exactly 5 red cards from the total 52 cards? Or I can say, what is the probability of drawing specific number of success? 5 red cards I can say is that is a success, specific number of success without replacement from 52 or from finite population. Again here, what is the probability? I can say what is the probability of choosing the K type A genes from 2J type A genes. That is basically the success. Suppose that is what they're trying to say from the finite number of from the finite population. Are you getting? In geometric distribution, it's like when will be the failure, and then success. And then here, the total number of success, probability of drawing the total number of success, there until the success we are doing. Here, what we are doing, total number of success from the finite population. Is it clear? Should we proceed?
Yes, ma'am.
Now, if I say that this PJK is suppose n cross 1, oh sorry, n plus 1 cross n plus 1 stochastic matrix, or I can say homogeneous Markov chain it is forming. Now, simple question, is this Markov chain ergodic or not? If I talk about this. First of all, I have to write this. Wait a second, how the Markov chain is formed. Now tell me whether this Markov chain is ergodic or not. What is ergodic Markov chain? I told you just now. Yes, come on. What is ergodic Markov chain?
A Markov chain is ergodic if there exists some power to which to raise to which the all entries are zero, greater than zero, positive.
Can I say if there exists a path greater than 0 or path, as you said that all entries are greater than 0 or there is a path. So what about
Yes.
this? Can we go from 0 to 1 here? As in the class it said that that we can't go from 0 to 1, but why? Can you tell me? J is 0 and K is 1.
As we have defined, when we have to choose after K out
Yes.
of 2J. That's why select 0. And after putting the values, then we get 0.
Can you repeat? Your voice was cutting again.
Then we have to select 1 out of 0, which is not possible. That's why it's 0.
Or can I say that 0 and 1 both are used for the J and K is basically the double, basically 2 are used for the parent, and then we'll go to the other state. The K will be the other one. Does it make sense? Or am I wrong? Maybe.
Please repeat.
What I'm saying is 2J we are saying 0 and 1 basically are for the parent, and then we'll go for the child. Is it like that, or there is no sequence or something? What is your view about this?
The first one is for parent and second one is for child.
First one is for the parent and second one is for the child. So if can it be that I'm getting that first J is for the parent and K is for the child. So can K be 1 if J is equal to 0?
No, ma'am. That's what I was saying.
That is what basically we can't go from 0 to 1. Basically we have 2J. Can I say that?
Yes, ma'am.
So if usually I told you that if there is no path, we call it as that it is not irreducible. It is basically reducible Markov chain. And if it is reducible, it is not ergodic. And if it is not ergodic, it is not at all regular also. Can I say this?
Yes.
Now coming to the another concept from the cell genetics only, which is martingale. Can you tell me what is martingale? I'll just give you vague intuition and then I'll go to the proper. If I am x is equal to, if I am in 20, I'll say, I'll go in 25, I'll go in 15. but on average, I'll be in the same state, 20. Can you tell me by this now what is martingale? Very vague thing I have written.
Ma'am, the expected
Mhm.
the expected state of the child is same as that of parent.
Yes, yes. Basically, the state will remain the same. I can say that 20 it was same, or this was just a vague example. If I'll come, basically the expected value will remain the same. That is what it means. Or I can say that like that all the if suppose this is the past information and conditional probability of the next value, basically it is equal to the current value, expected value of the expected future value of the process given all the current and past information. It is, I'll just write like this for the what is martingale property. I'll write in more easy way, then I'll go to cell genetics example. I'll write the property instead. Is it correct? Can you read and explain this? Yes, come on. That is what it is in. Now I'll write this about the cell genetics, then we'll compare. Now can you compare it and tell me? Is it the same?
Yes, ma'am.
So basically, martingale property tell us that the future value of the process basically is exactly the current value, or I can say the parent in EJ, what we are saying is expected to give the birth of the child in the same state, that is J itself. Am I correct by saying this?
Yes, ma'am.
Let's see. Basically, this is the definition of the martingale expected future, which with their saying as child. It is basically the current value itself, which means that it is in the same state itself. Can I write like this? The expected value. Now, as we have already written that this is basically PJK, we have already studied how we came up with this PJK value. Let's substitute those value from the above, multiply by K. Just taking it out. Just some transformations and all, not going in deep of that, how we are coming up with this. And then we are getting this J value. I'm not going in all this, just want to tell you that the future value basically it's in the same state, that is basically the martingale property. That is what they are trying to say, that they lie in the same state, that is J itself. Like we were going from J to K, and when the child after the expected value of the child to give the like if the parent in EJ basically is giving the birth to the child, it will be the same state as J, that is of the child itself. Should we proceed? What are absorbing states? What are transient states? Any idea?
Ma'am, absorbing states are those, ma'am, in which if we enter, we can't leave them.
Yes, absolutely correct. Basically, we can't come out of that. Once we have reached that state, we'll end up in that state itself. Am I correct by saying this? I think again there was an example. Can you go to the question number 4 of assignment 6 and tell me which one is the absorbing state? We have Markov chain, and there is at least one absorbing state. Consider the two Markov chain, and the question is which one of them is it? Okay, I'll draw it and then we'll see. Now, can you tell me there exists a absorbing Markov chain or not? Like there exists a absorbing Markov like state or not, and is it a absorbing Markov chain or not?
Yes, ma'am.
Which one is the absorbing state?
Ma'am, E.
E. Only one absorbing state is there or multiple?
Ma'am, A is also there.
Okay, let's come to that afterwards. I'll also give you one more example, then tell you. I'll come to again that example. This is also the assignment problem only. Now tell me, which is the absorbing state? Is it absorbing Markov chain? Yes. Come on. Yes, yes.
Ma'am, A.
Okay. The answer is that only Markov chain 1 is absorbing state and absorbing. This is not an absorbing state. Why? You are saying that A is absorbing state, but I say no. Can you think? Give a guess. Look at this very carefully.
Ma'am, because since A in the second one, if A is the absorbing state, then
Hmm.
we can go from any state to the absorbing state. But
Absolutely. Hmm. Yes, yes, yes. Come on.
but for this one, we
Hmm.
cannot.
Hmm. Carry on. Can you go from D?
No, ma'am.
Huh. Absolutely correct. You were also right. The other person, you were trying to say that okay, it is if we are entering in A, it should enter in A, then it shouldn't go in elsewhere. But there is one more property that one, like it should be accessible from every other state. If I'm going from E, basically I'll never enter that absorbing state in that Markov chain. If I am going from D, I'll never enter that absorbing state. Basically, that absorbing state, can I say it should be accessible also?
Yes, it should be accessible. At least one of the absorbing states should be accessible.
Yes, absolutely correct. And in this also, I'll say that E is not basically the absorbing, or I can say A, basically it was not accessible, but in this case, E was accessible from everyone. So that's why we call it as E as a E is absorbing state and absorbing Markov chain. So basically, I can say that accessibility is also a
But
property. Yes,
but
yes.
A can't access B in the first graph also.
Yes. Wait a second. Let me see the question. Have I copied it correctly? Yes. You're also correct. But absorbing state should be accessible. Now the question is, then why, how I can say that this is basically, you are also correct in this. Basically, we have this property that it should be accessible. Then I can say that it is also not the Markov chain, absorbing Markov chain, because it is not accessible from A, as you have pointed out very correctly. What are others' views? Maybe they have written incorrect, because absorbing the properties of absorbing state says that there should be non-zero probability, or I can say that there should exist a path basically to the absorbing state from every other state. Maybe we'll come up with the in the next class, I think so. Then if we are saying that A is not accessible from every other state, then E is also not accessible, and then it shouldn't be also the absorbing Markov chain. Does it make sense?
Yes.
Maybe if I'm missing something, I'll come up with the next class to tell you. But maybe I think so. They have written incorrectly. Both are not the absorbing Markov chain, because if A is not accessible, then E itself is not accessible from the A. Basically. Basically, we all, because as we have an accessible property that it should be absorbing state. First thing that it shouldn't just if I've entered that state, I can't. Usually, we do uh, like uh, symbolize it like this, the double circle. Though they haven't done this, but usually we do it by the double circles, stating that it is an absorbing state. Maybe they are asking the question, so obviously they'll not do. And okay. About accessibility, it should be like it should reach from every other state. Although it's not necessary that it should reach in one step, but in multiple steps we can't reach from D. Oh, sorry, we can't reach to E basically in multiple steps as well, because okay, okay, okay. But from A, E is is not possible because A itself is absorbing state, but A is not accessible. Okay, this is absorbing state. Tell me why. I got the click now only. Read this, two things. Now tell me why E is absorbing state and this is absorbing Markov chain. Is A a transient state? Yes, any idea? Is A a transient state? But it's not an absorbing also. I think so. There is some confusion because B, D, C, I can say that they are A itself is not going to anywhere. So we can't say A is a transient state, and B, D, C are transient states because they are going from somewhere to anywhere, and they are reaching E, and E is basically the absorbing Markov chain, absorbing state. Does it make sense, or there is still confusion? In other
Still
words,
don't got.
yes.
I don't get that, ma'am.
You're not audible. Can you repeat?
I'm confused, ma'am.
I'm also like, what I mean to say that transient states, what are the transient states in this example? What do you think?
B is a transient state.
B, D, C are transient state. What about A? Can we say that A
A,
is transient state? But the thing is, transient states are one, like that once left, I can say that the probability it will not return, or I can say
And transient are those other than absorbing.
other than absorbing. Then the other question is that if we are saying that A is not absorbing, then how can we say that A is not transient itself? So maybe I'm not sure. Maybe I'll come up with the better explanation. I think so. Okay, let's come up with the explanation in the next class. This for sure is not absorbing Markov chain, but if this is not absorbing Markov chain because A is not accessible, your claim that how then E is also there because from A we can't go to E. That also makes sense, but A is itself not going to anywhere. Okay, I'll come. Please remind me in the end of the class, or okay, I'll remember. I'll make a note that how basically I'll come up with the next class, and I also say you do some brainstorming. You should also come up with that how this is basically is basically an absorbing state. Is it fine?
Yes, ma'am.
What about the other person? Is it fine? Let's proceed. So, so now let's come up with some practical problems of probability. Uniform sampling. Before going to or jumping to problem, can you tell me what is uniform sampling? As you mentioned now only told me that doubly stochastic matrix that was uniform distribution. What is uniform sampling? Yes.
In a given range, choosing a number.
Choosing a number with equal probability, can I say?
Yes, ma'am, with equal probability.
So let's have a problem here. Suppose given an integer m and unbiased coin design, an algorithm, uniform sampling from 0 to m minus 1, we have to. I'll write first and then we'll discuss to pick random x from 0 to n minus 1. So what we are doing, we have given an integer and an unbiased point. Basically, we have to design an algorithm to pick randomly from these 0 to m minus 1. What is the idea? What they are saying is toss the coin as many as times. Basically, I'll write the algorithm, then I'll count. Sorry. The ith toss. And if x is greater than m, then go to 1, else output x. Can you tell me what they're trying to do and can you show with the example m is equal to 5? What we'll do? Come on.
We are tossing log 5, log 5 times, log base to 5 times a coin, and then forming a string, forming a binary string, and after that converting it into decimal number, which is into the range of 0 to n minus 1. That's why, and then if not, we are repeating that experiment.
Can you do for m is equal to 5 and share the screen and show me how this algorithm will work? Take random head, tail, head or something like suppose take first time head, tail, head. Just try. Should I stop sharing? You will share. Try. I will help you. Is it fine? One of you can share your screen. Is it fine? Should I stop sharing? Have you noted?
I don't have the facility, ma'am, to write.
Okay. So sorry. Or you can write in page and pen and then okay. Then is it possible to okay, then click the
Can I dictate?
yes. That's better option. Now m is equal to 5. What will be k?
Ma'am, log base to 5.
What is that? It is ceiling. I'll tell you first. Can I say this? You got it? How? Or should I explain? Yes. Basically, seal, basically 2 twos are 4 and as it's the upper bound, so 3 basically rather than 2. And then what is x?
X is the result, that is 0 or 1.
X is what is okay. Now can you expand this? Suppose I got head, tail, head. Head means 1, tail means 0, and head means 1. Is it like that?
Yes, ma'am.
Now can you tell?
After that, ma'am, we convert that binary string that is 101 into uh, into decimal number. Ma'am, that and if that number is in range of 0 to m minus 1, that is 0 to 4, and then we keep it, else we throw it and we repeat that.
Now basically it's 5. So basically x is also equal, basically m is also equal to 5 and x is also equal to 5. Then we again toss it and we do it. Is it fine?
Yes, ma'am.
I can say, how does uniform sampling happen? Suppose I do it, suppose 8 times. I'll write like this and then they will come. So what is the probability of here getting the 0?
One
Just
by
what is the probability of getting these zeros?
1 by 8.
Basically 1 by 2 multiplied by 1 by 2 multiplied by 1 by 2. What about others? Same.
Yes, ma'am.
This is basically what we are trying to do, that all will have the same probability. Now, this is just the intuition what I'm giving, that is uniform sampling. What we do is probability that output is t, I can say it as probability that x is equal to t or I can by conditional probability, oh sorry, by Bayes theorem, I can write it as conditional. Can you tell how we transition to this? Conditional. Is it correct?
Yes, ma'am.
Conditional probability. Should we proceed?
Yes, ma'am.
So basically the value of this, when we'll solve it, basically we'll get it 1 by n. That is what we were trying to say earlier also, that they'll have the equal uniform probability, that is 1 by n basically. Now, what is the expected number of time? Basically it is executed, suppose, or I should, I think, proceed. Should have written here basically. This total number is basically m over 2 power k. So if I get success in the first time, I'll say m over 2 power k. If I don't get the success, which means the failure, this is success, I'll say 1 minus m over 2 power k, then I got the success. This is m over 2 power k, second time. Suppose I got it third time, failure, failure, then success. Can you tell me how it will be? How it will look?
1
This is
minus m by 2 raised to k,
hmm.
2 times, and then m by 2 raised to k.
Basically, this is third time I got the success. That is how it happened. Now let us take it as 1 minus m power 2 kV delta. And Let us take this the other side, which means taking it common and taking it other side. 1 plus, I can say this, we have taken it as delta. Delta, this is other side, which means 2. Similarly, delta square, 3 and so on. Subtracting these two equations. Right first. Missing the things. I'll just go again. Just I'm writing it and then we'll go again. Now subtracting. So what I have done, this was as we saw that this is success the first time, failure, then success the second time, failure, failure, then success the third time. And let us take as 1 minus m delta k, m over 2k, we basically the delta. We shifted this m over 2k this side, basically take it common from everyone and shifted that side. This is basically delta. And then let us multiply the delta with each of them. That is what we have done, and then subtracting it. Is it clear? Should I proceed?
Yes, ma'am.
1 minus delta plus delta square and so on. And this 1 minus delta is basically this is basically delta is basically m by 2 power k. 1 minus m power 2 power k. We'll get it as mu only, and this is basically.
It should be, ma'am, it should be 1 plus delta and then delta square.
There, okay. 1 plus delta square. Is it like that?
Yes, ma'am.
But we are subtracting, ma'am.
And we are subtracting second from 1.
Okay. I'm still not getting. Yes, okay, you're saying that we are subtracting second from 1. Okay, then we'll get 1 plus delta square. Is it so? Are you sure?
Yes, ma'am.
Okay, now what is this? Yes, it makes sense. Now what is this distribution?
GP.
GP, geometric sum basically. Geometric distribution. That is what we are getting now. I'm still confused about this. Delta. Maybe I'll go through this again. And what is the answer?
One by 1 minus.
Yes, absolutely correct. Basically, it is basically, I can say that it is less than 2, or I can say that it is algo is expected to stop in 2k tosses. 2 power k tosses, basically log m, I can say in the other words. That is what they're trying to say, that basically the complexity of this is log, which is very small basically. Still, I have the confusion in this part. Okay, I'll check that. Similarly, we have done the same type of problems. I'll not maybe, so let's just have the glimpse over it. Given km, you want to pick, just tell me in short how you will do this. I'll just rush and then we'll go to the hashing part, because these are similar problems. Can you tell me? First, can you read the question and tell me what they're trying to do?
Sampling k numbers from 0 to n minus 1, given k and given k and n, you want to pick a random s, which is in subset, which is in set num 0 to n minus m minus 1 of size k.
Now, can you tell me what is the idea? How we'll do it?
And we are repeating the previous experiment again and again to get more k numbers.
So basically, we keep on picking an element till, or I can say the new one. I can say that I want to get the new element. Is it fine to say this?
Yes, ma'am.
So I'll not write the algorithm, just the same as this. We'll uniformly pick it, repeat it, and then keep it in suppose S subset, and basically picking the new one. Now let us come to the analysis. Let us say I'll not go for okay. I unique number you have picked. Now, how many are remaining? From M, how many are remaining? Total M are there. How many are remaining? I unique numbers you have picked. How many are remaining? Can I say
M
M?
minus 5.
Out of total M? Is it correct to say?
Yes.
Or can I say what is the probability of that? Is it correct? Or something missing? Or we should go, I'll go by step rather than going through this. Okay, let's follow that. Suppose I'll go for step by step, then we'll come to this discussion. Let I is equal to 1 and 2, and T1 is not equal to T2. What does it mean? We need to have the unique number. That it means, can I say this? Now, probability of T1 belonging to S, probability, I'll write it and then can you explain what I have written? Can you tell me what I have written now? What does it mean? What is intuition? What I'm saying is that T1 and T, yes, come on. I'll first write.
Ma'am, we are repeating 2 times this experiment. And first time, ma'am, we are getting T, and then we are, ma'am, getting T2. That's why, ma'am, and then the second time, ma'am, we get T1.
So basically, if I want to have in the set T1 and T2, either the thing is, the two things can be there. Either T1 belongs to S, I can say, and then if T1 belongs to S, the second one should be X2 or T2. And if suppose T2 belongs to S, the second one should be T1. Am I correct by saying this? What is the probability that T1 belongs to S? Can I say 1 by P, that is 1 by M?
Yes, ma'am.
And what is the probability that T2 belongs to S? X is equal to T2 if T1 is already there.
1
is
by M minus.
Similarly, can I say this? So basically, when we'll solve this, basically this is also the uniform probability. That is, and if I'll go for the K, that is basically this thing. That is what they'll extend, and then I'll not do that thing. That is the simple thing. That is this thing only, which I explained you, that how we get the number of iterations. That is what they're trying to prove, that still we get the very lesser iterations, very less, like the value of the K. Basically, the complexity is very less, basically. Now, again, there was a question of biased point loss that I think that is similar to that. Should I proceed for the hashing thing or should I go with that question? Biased point loss, it's similar to this only, like and then permutation and all. Should we proceed to hashing? Because those are the similar ones only.
Okay, ma'am.
Yes. So what do you think? What is hashing? Why we, first of all, why we use it? Maybe I'm rushing a lot. I should slow down now. What is why hashing is used? Basically, mostly you have seen in data structure. You have studied data structures.
Ma'am, to get data in constant.
To get the data in the constant time, I can say, or else, okay. Can I say what is the advantage? As you said, what is the advantage of hashing over array? That to search in constant time, though basically for storing arrays also taking big go of one, but for searching, what is the array, the complexity for the searching?
Big O of 1.
For array, if I want to search in an array,
Big O of n. Big O of n.
big O of n for linear search. What about binary search?
Log n.
So can I say big O of log n? So, but what about hashing? Basically,
Big O of 1.
So basically, why hashing comes into picture, that we have lot of data in internet, the amount of data is increasing, and obviously we came to data structure hashing so that we can in constant time search anything. So it's like, I'll just give an intuition and then we'll proceed. It's just like, I have these keys here. We have this hash function, and then we have this index value. Can you tell me what is what I have? What will this hash function do, and how it proceeds? What is hashing? How it will do?
It acts as a function that is one-to-one mapping between key and value pair.
Yes. So basically, the hash function, can I say that it will receive the input key and will return the index? Now let us take a very toy example. Suppose I have the string AB, CD, EFG. What does my hash function do? Basically, it calculates the hash value. I can say the index of the data. What I am doing is I am assigning A is equal to 1, B is equal to 2, and so on. So what will be my AB? I'm adding it, basically 3. What will be my CD? Can you tell me?
7. 7. 7.
7. What will be my EFG?
18.
5 plus 6 plus 7, 18. Yes. Now I did it. And what I say that the table size is basically, suppose there are many ways, just I'm giving you the intuition because we'll not go that much into the data structure as well. Just intuition. So table size is 7, suppose. And what I'm saying is sum of the string which we have done, mod 7. So what will be AB? When we'll keep in the table in the index, what will be the index? That is basically the hash function which they are using. So what will be the AB?
1
3 more.
into
What will be CD? Yes, come on.
7. 7 mod 7.
7 mod 7. 0. What will be EFG?
4.
4. 18 mod 7. Now, can I say my table will be like this? 0, 1, 2, 3, 4, 5, 6, and CD will be 0 in 0 index. AB will be here, and DFG will be here. Is it correct? This is how we do this.
Yes, ma'am.
Okay. Now, if I want BA, where will BA lie?
Same as AB.
Hmm?
Same as AB.
Same as BE. Now, what about BE? Can you calculate BE and tell me where will BE lie?
In place of CD.
CD. So what is happening? Can you tell me what is the problem which is happening?
When
Collision
we are
is happening.
mapping,
Yes, absolutely correct. Collision is happening. The problem is basically different strings basically are giving us the same hash value. Same hash values are generated. So that is why collision is happening. What can be done to improve this collision?
when linear chaining,
That is the other thing. The naive approach will not go to chaining and all. Naive approaches, can I say, like to increase the
and
table?
like we can increase the size.
Yes, yes, absolutely correct. So we can increase the size of the table. So in the class, actually, that is only taught basically, but some of the examples are taught like what can be the hashing example like shortening of URL, encryption, signatures, and all. And what they are talking about is pairwise independent. Can you relate now with something? What is this pairwise independent? Can you tell me how we can relate? What is pairwise independent? What is independent function? You know about that. Now, what is pairwise independent and how can we relate with hashing?
When two taken at a time are independent of each other.
What? Yes. Can I say in other words, this is only what they're trying to say that they should have different hash values. That is only pairwise
Yes, ma'am.
independent. There should be no collision. That is only pairwise independent. Whatever they have taught, that is the conclusion is that if the values they are pairwise independent, basically they are basically the collision is not there. They're having the different hash values and how they are managing it basically by taking bigger T, that is bigger table basically. That is what they're trying to say there. So, and then maybe the cryptography and all. So now they came up with the cryptography example. I'll just come before starting this. I'll come in 5 minutes. Let's meet in 6:35 or let's have a break, quick break. Then I'll complete this cryptography example and the assignment problem of sixth assignment problems. Is it fine?
Yes, ma'am.
Next Saturday, Sunday, we'll try to complete all our session. So 6:35, let's meet again. Okay, let's start the class again. Am I audible?
Yes, ma'am.
Okay. So I'll just give you the intuition behind it. Any idea what is the what is cryptography and why it is used? How it is used before going jumping to next thing? Yes. Which purpose it is used? Yes, come on. What is the purpose of using cryptography? Come on, come on. Yes, why we use cryptography? And how?
It is used for encoding.
It isn't used for encoding, decoding. I can say for the security. Can I say that? So basically, now they are just giving an example like Alice and Bob is there, and basically an Eve that is an attacker that is coming in between. And what is the possible solution? Can you suggest what is the possible solution? That if a message is sent from A and it is sent to B, then what can be possible solution that it shouldn't be tampered or he can what can he can do? He can change the message, he can add the noise, he can basically tamper that message. So what and then send it to B. So how B will get to know that the message is not from A, the message is from the attacker? Is there a solution?
They can share a signature thing that can they can how that's
Yes.
how they can identify each other's method.
Yes, yes. So basically, they can share the signature thing. That is basically the hash function itself. They are sharing it, and then they are basically checking. Like A is sharing, like both of them are having that secret key. That is the random key. Both of them are having. Then A is sending the message with the signature. B is accepting it and checking whether it's from A or not. Now, what is the other thing which is taught that how it got steel and the chance, but still I can say the chances of collision are very small. Maybe we'll discuss these all things in the next lecture. And I don't want to go in detail now only because of less time. We'll go with we have to go with the assignment 6 as well. Can you all open this assignment 6? This was just the intuition behind why what is cryptography. We'll come up with in detail like how if we basically steal that, what will happen and all. Just an intuition what that I have given you. Can you open this assignment 6? Can someone read and tell the answer of the first question? Yes, come on. Come on, come on.
If P is K cross K transition matrix with all entries non-zero, then limit n tending to 0, P raised to n is, we have to find that.
So what is the answer?
The answer is exist n is a rank 1 matrix.
How? Basically, I haven't basically discussed, or I don't know whether it's discussed in class.
It is regular. We have all entries non-zero. That's why, it is regular, and then limit must exist. And
limit is existing. That is okay. That exists. How rank 1? Basically, this theorem itself
it was
says
told.
that. Yes, yes.
It was told in the class itself that.
Okay. Then I missed it. That if we have a reducible positive entries, I can say that we'll have. Can I say that we'll have the unique? I'll say largest real number, and it will be if it is told, then it's fine. Basically, they'll be positive and the corresponding eigenvector also. And the rank will equal to 1. Basically, the definition of this tells us. Let's proceed to the next question. What about this? Can you tell me? Let M be the transition matrix of the Markov chain between 2024 states. By applying repeatedly, the limit of applying M repeatedly, what is the trace of M bar? What does stationary distribution mean? Can I say that it will now the probability values will not be changed? Can I say that? Am I audible?
Yes, ma'am.
So can I say that the probability values will not be changed? Actually, the doubt I'm having is what is trace now? The sum of the diagonal entries. And if we think that they are the sum of the diagonal elements, which means it should be this. What is this? GP. And if you'll solve this, you'll get the answer. Any doubts?
No, ma'am.
The next question. Let's make 1, 2, 3, 4. 1, 2, 3, 4. 1 to 1. Is there a path? 0. 1 to 2. 1. First, I'll read the question. There is assume that path departing from the shop by treating each path equally. Okay. Now, can you tell me 1 to 3? Is there a path? What is there? 0. 1 to 4, 0.
Yes, ma'am. 0.
Next row, can you tell me? 2 to 1. What is the probability?
1 by 3
1 by 3. 2 to 2.
and 0.
2 to 3.
1 by 3 and 1 by 3.
How 1 by 3? Now, can you tell me why you told 1 by 3?
And all paths are equally likely to be chosen. That's
So
why
all paths are those. So there were 3 paths, 1 by 3 for each path. Now, what is the other row?
0,
0.
0, half, 0, half.
So basically 2 paths, so equally. 4 to 1.
And 0, half, 0, and 0, half, half, 0.
So now, is it irreducible? Oh, sorry. Is it ergodic regular? What is the answer?
And it should be ergodic only.
How it is ergodic?
And n square is have positive entries.
That is regular also. Ergodic also have the condition it should be reducible, which means there should be a path. Okay, one more thing. Square is positive. Okay, that isn't regular. What I'm saying is from 1 to why is it irreducible or not? There exists a path from each node or not? The other question is, can you tell me? Is there a path from every node to the other node?
Yes, ma'am.
Yes. So, but this is 0. Is there a path from 1 to 3?
And n square there is
Can I say 1 to 2 and then 2 to 3? There is a path. I'll go from 1 to 2 and then 3. Or what about 1 to 4? Again, 1 to 2 and to 4, which means from 1 to 4 also there is a path.
single step we can't move, but in
Single step we can't go, but
two or more steps,
it is what I mean to say. All the nodes are reachable.
yes, ma'am.
So can I say that they are irreducible? There exists a path.
Yes, ma'am.
So can I say they are ergodic as well as regular?
Yes, ma'am.
That is what basically it says. And is it okay? Aperiodic and periodic. Let's leave that. So next question we have all next two questions we have already done. Like though they are saying only chain one is absorbing, I am also thinking because of A is transient or not. Okay, we'll discuss for the chain one in the next. Chain two, we are sure that it's basically not absorbing. And the question 5, as you have only answered, that it's 1/4, 1/4 with equal uniform distribution. So from the next lecture, that will be the last, maybe the second last. I'll try to cover everything, and if we have the revision lecture on the Sunday, I'll try to complete that. Any doubts? Please, can you
Sixth
suggest?
question.
Which question?
I'm only that sixth question of I mean, fourth question of sixth assignment.
Fourth question. Fourth question. I'll check and inform you. Because absorbing state. Okay. I'll again go through it and I'll inform that. So let's meet in the next lecture. Thank you, everyone. Okay, class.
Thank you, ma'am.
Thank you.